Yeah, okay. Please turn your cameras on. Okay. So I'm going to share with you file, and then we'll discuss review. So first topic is differential equations. So this is example of differential equations. 3x plus 17y equals 25. Now we can write. Oh, sorry. So in general, we can write ax plus by equals c. So in this case, if it's written 3x, what we write in a equals, help me, a equals?
A equals 3.
So then we see coefficient for y is 17, so this is b equals 17. And on the right hand side, we can see 25, so this means c equals 25. So the first step is find d, that is greatest common divisor of a and b. And first, and also we can mention if d is greatest common divisor of a and b, left hand side is divisible by d. So this means ax plus by is divisible by c. But left hand side equals right hand side. So this means what we can expect from this solution exists if only if c is divisible by d. So in this case, d equals greatest common divisor of 3 and 17, d equals 1, and of course 25 is divisible by 1. So solution exists. How to find solution? So we have two formulas right there. One formula for x equals x naught plus, and you need to memorize these formulas, b times t, and y equals y naught minus a times t. So we write in x, but coefficient for t is related to b. So this is b. And we write in y, and coefficient we related to x. So this means a. So x naught and y naught are particular solutions. So to find these particular solutions, we need to rewrite our differential equation. No, write it, and then I move to the next page. So differential equation. So to do it, so we'll take this equation, 3x plus 17y. 3x plus 17y equals 25. And we need to take one of the terms on the left-hand side and move on the right-hand side. And we move term with largest value of the number. So we have 3 and 17. So this means what we'll write on the right-hand side. 25 minus, so what we choose, 3 or 17?
17.
So 17y, and still 3x on the left-hand side. And now what we can see, left-hand side is multiple of 3. So this means left-hand side is divisible by 3. So we expect this expression also divisible by 3. Okay. Now we need to find x and y such that we have this equality. So, and what we're going to use, we will substitute specific numbers. What we can write instead of y? Because this is divisibility by 3, so we will see what are possible remainders when we take number and divide by 3. So how many remainders we get if divisibility by 3? So how many remainders? We have 3 remainders. 3 remainders, and possible remainders are 0. So number is divisible by 3. Remainder is 1, and remainder is 2. And now we will step by step, we'll take this formula and we replace y by 0. So y equals 0. and we'll substitute in this formula. What we'll get? 3x equals 25. And definitely, you cannot solve this equation in integers because 25, it's not divisible by 3. So we cross 0. So y equals 0, it's not solution of this equation. So what is next value? Y equals 1. And we write in 3x equals 25 minus 17 times, no, help me, times what we write? One. Instead of y, 1. 25 minus 17 is 8. So 3x equals 8. So no solution. So we cross and 1 also because no solution for x in integers. So now use y equals 2. Write it. Y equals 2. So what we get? (3x) equals, no, help me, 25 minus
24.
17, 51. 17 times 3. Or 17 times 2. So what we'll get? It will be 34 with minus and plus 25. What we get? This is negative 9. And x equals
Negative 3.
negative 3. So what we can see, so only one value works. It's y equals 2. And for this value y equals 2, we'll get x equal negative 3. So this means when we apply this formula now, so we know what is x naught. X naught equals, what is x naught? X naught, negative 3. So plus b is 17 times t. And what about y? Y equals, no, give me first term.
2.
This is from here. So we get y equals 2, x equal negative 2, then minus a is 3, and then times t. This is formula for all possible solutions of this Diophantine equation. And if we substitute different values of t, so we'll get different pairs. So this means infinity many solutions. This formula gives us infinity many solutions. 0, if t equals 0, we'll get x equals negative 3, y equals 2. And then we can substitute 1 or negative 1. So, and then plus 2 or negative 2. So this means using arbitrary value of the integer t, we'll get different pairs of the solution. So this is what we need to write for answer. Okay? So now let's practice. This is important equation. Let's practice. I'll give you, no, write it. So I'll give you one more equation. I stop this sharing for a second. And now I share a whiteboard. No, give me an equation and we'll solve it right now. So like x times y and equals. No, give me coefficient for x. No, something not really big. Yeah, yeah, no, that's right. 5x, and then let's do minus
19.
19y equals
27.
no 27. Yes, good. Okay, so first of all, we're writing a equals 5, b is 6, b equals negative 19, c equals 27, greatest common divisor d of 5, and we can write 19 or negative 19, so equals 1, so 27 is divisible by d, divisible by 1, so we can find solution. Solution exists. Now, when we say a solution exists, no, actually we have infinity many solutions, but we have only one solution that given with help of formula what we wrote. Okay, so just only one formula. for x and one formula for y. So in this sense, it's only one solution, but no more formulas. But if, of course, it's for different values of t, we get different pairs of x and y. So what is next step? So find x naught and y naught. So particular solution of this equation. So we need to rewrite this equation. How we can rewrite? 5x minus 19y equals 27. What we get? So what we leave on the left-hand side? Smaller number. So
5x
mm-hmm.
equals 27 plus 19y.
Good. So now we will, instead of y, we'll substitute specific numbers. Which numbers we can substitute? So it depends on what is written right there. Left-hand side is divisible by 5, so this means what we can use. Y equals 0, 1, 2, 3, and 4. Divisible by 5 cases. And now take this formula and substitute instead of y 0, 1, 2, 3, and 4. Or if you don't like big numbers, you can write 0, 1. Instead of 4, if I'll take 4, subtract 5, we'll get negative 1. If we'll take 3, subtract 5, we'll get negative 2. And then 2 right there. So you can use this. Let's do it. Or you can use these numbers. Okay, no? And so check from this formula, find from this formula value of y such that x is integer. Tell me, Anton.
Two
Y
works.
equals, which value works?
2.
No, let's see, y equals 0. So 27 plus 19 times 0, 27. So 27 is not divisible by 5. So we cannot use 0. And then y equals 1. So 27 plus 19. So it will be 46. 46 is not divisible by 5. And now let's use y equals 2. So what we get? 27 plus 19 times 2, and we expect it equals 5x. So 19 times 2 is 38. 38 plus 27, 7 plus 8, 5. Yeah, good. 65. Yeah, 65. So 5x equals 65. X equals 13. And y equals 2. So now right answer. X equals y equals.
Should it be 13 plus
13 plus, so formula is x equals x naught plus bt, y equals y naught minus 80. So what we write in x naught, this is x naught 13 plus b. Where's b? B equals
negative
19. 13 minus 19t, and y equals, so what we write in y equals 2 minus 5t, and t equals 0 plus minus 1 plus minus 2. So this is answer for problem. 100% you'll see something like that on the test, okay? So, okay, let's do next problem. No, write this. Okay, can I raise it? Yes? Okay, clear. Option. Then back to the file. What about this equation? Also a Diophantine equation, but what we can see immediately, d greatest common divisor of 66 and 10, it's not 1. Because 66 is divisible by 2, 10 is divisible by 2. So this means we can apply some kind of general formulas, and in my notes you see general formulas, but I prefer reduce this problem when now everything, each coefficient is divisible by 2, 66, 10, 24, to problem that we have on the previous page when d equals 1. So this means instead of writing a equals 66, 10 equals b is 10, and c is 24, I will simplify this expression. This is the idea. If it's possible, simplify it immediately. And if you simplify, you'll get immediately d equals 1. Okay? So what we can do? No, if we have solution, then d equals 1. So divide by 2. What we'll get? 33x plus 5y equals 12. Now we can write a is 33, b is 5, c is 12. What is greatest common divisor of 33 and 50 and 5? So what is it? What we can see? What we can see? So 33 and 5, greatest common divisor is 1, and 12 is divisible by 1. So solution exists. Now we're going to use the same formula that we just used in previous example, but first we need to find x naught and y naught. To do it, I'll take my equation and I will rewrite it in different form. We need to move one of the term on the left-hand side on the right-hand side. So what will move from left-hand side on the right-hand side? Expression with larger number. What is it? 33 or 5? What will move on the right-hand side? So what we write? 12 minus, and what is next term on the right-hand side? 12 minus, say it. 12 minus, we need to write smaller number on the left-hand side. No, say it.
So
what?
33x.
33x, good. And 5y on the right-hand side. Now expression is divisible by 5. So this means for x, how many cases we have for x? If divisibility by 5, how many remainders we have?
5.
5. We write and remainder equals 0, 1, 2, 3, and 4. Now use this values of x and tell me x and then y. So what we get? 0, 1, 2, 3. Only one number for it works. Okay. So what we get? 5y equals 12 minus 33 times 4. 33 times 4 is 132. Minus 12, 5y equals negative 120. Y equals, you need calculator for test. Y equals, what we get? Y equals
Negative 24.
negative 24. Okay, this is y, and x equals 4. No, right answer. The answer. So what we get? X equals x naught. What is value of x? We just find it's x equals 4. So this means we're writing 4 because x equals 4 plus b times t. So this means plus 5t, and y equals, no, write it, y equals y naught equals negative 24. We write negative 24 minus a times t, and a is 33 t. So t equals 0 plus minus 1 plus minus 2 and so on. Okay, let's go to the next page. Okay, so next example, solution does not exist immediately. No, we can say no solution. So let's see why no solution. What is A? No, help me. A equals 8. A equals
6,
6.
B equals
9,
9. So we need to find greatest common divisor of 6 and 9. This is 3. So, but C, so this means left-hand side is divisible by 3, but right-hand side is 13, and 13 is not divisible by 3. So what is answer then?
No
Answer-
solution.
No solution.
No solution. Okay, good. Now, so definitely at least one problem like that on the test. So, I mean, we discussed with you, 4 problems already. And also one we need to find solution, and maybe from the text problem or just solution that is positive or non-negative, okay? So let's see problem with application. So okay, now let's do this Euler problem. Okay. So now let's read it. This is from homework. Divide 100 on 2 expressions, sum. So one is divisible by 7 and second is divisible by 11. So this means it's about not division, about representation. Number 100 is sum of 2 expressions, divisible by 7. So we're writing 7 times 6. And second is number divisible by 11. So 11 times y. And also it's written positive, some kind of restriction on x and y. Or in this problem, actually I solve non-negative. Non-negative. So if it's positive, x greater than 0, y greater than 0. But if non-negative, so x greater equals 0 and y greater equals 0. So we need to find these solutions. So how to do it? So to find these solutions, first of all, we need to solve this equation. So like we did it, 7x plus 11y equals 100. A equals, let me erase it. So not only solve equation, you need to write equation from the text of the problem, and then you need to write inequalities and find all solutions such that satisfy equation, but also then like positive or non-negative. It depends on statement of the problem. No, this case I wrote positive, but also we can solve it like non-negative, just different case. So let me erase it, and we'll do it right there. 7x plus 11y equals 100. So what we're writing, a equals 7, b equals 11, so c equals 100, d is greatest common divisor of 7 and 11 equals 1, 100 divisible by 1, solution exists. Now we need to find solution. X equals x naught plus at, y equals y naught minus, this plus bt minus a times t. So, and then we need to find solutions such that x greater equals 0, y greater equals 0. So I'm solving special case, non-negative. It will be clear from the statement of the problem. So, for example, if it's problem about like coins, number of coins is non-negative, okay? So if problem about ships or cars, so also non-negative, okay? So no, let's do it. So we're writing 7x plus 11y equals 100. So what will move on the right hand side, 7x or 11y?
11y.
11y, good choice. 100 minus 11y. So now we need to choose divisibility, because divisibility by 7. So we have how many cases? 0, 1, 2, 3, 4, 5, and 6. So 0 doesn't work. 1 doesn't work, 2 doesn't work, 3 doesn't work, so y equals 4 works. Okay, so what we'll get? Y equals 4. So, and let's check it works, because 7x equals 100 minus 44, 11 times y. and 7x equals 100 minus 50, minus 44 is 56. So what we'll get? Y equals 4 and x equals 56 divided by 7, 8. So now write solution. Like this. Use this formula. Tell me what is answer. Answer for solution, but it's not answer for solution of the problem. So what we get? X equals x naught 8 plus b 11 t and y equals 4 minus 7 t. But what is required? This is important, and definitely I'll give you something like that when you need to solve inequalities. So what we expected, x greater equals 0, y greater equals 0. So this means we'll get two inequalities, a plus 11t greater equals 0. And then second inequality is 4 minus 7t greater equals 0. So to solve inequality, linear inequality, we need to rearrange, we need to rewrite terms in inequality. How to do it? We need to move some terms on the other side such that in front of the t you expect it to get positive number. So it's written LA plus 11t greater equals 0. So we leave 11t, it's already positive. We move only negative 8 on the right hand side, change in sign. So this means t greater equals negative 8 over 11. This one solution. And what about 4 minus 7t? How we can write it? So what we get on the right hand side? We need to move such that in front of t we get positive number, but right now it's negative number. So this negative 7. So this means what we write on the right hand side? Say it.
7t.
7t, good. Less than equals 4. Or t less than equals 4 over 7. Okay, now I will draw a real line, and I will write 0, then 1, 2, then negative 1, negative 2, and I will plot points negative 8 over 11. It's between 0 and negative 8 over 11. And then number 4 over 7, it's between 0 and 1, 4 over 7. And on this interval, we need to find integer points. And what we'll see from this, how many points t we get integers between negative 8 over 11 and 4 over 7. How many integer points you see of this interval?
1.
Just 1 point, t equals 0. So this means how many non-negative solutions? So answer is only one solution for t equals 0. So this means what we'll get, x equals 8 plus 11 times 0, 8, and y equals 4 minus 7t, t equals 0. So this means y equals 4. So this is answer for problem. Write it, and then we'll go to something else. Okay. You see, by the way, in my notes, more example like this with inequalities. I will leave you to think about this by yourself. Now let's talk about prime numbers. And okay. You can see more problems with inequalities. In this one, more problem. Okay, so okay, let's do this problem first. Find prime factorization. No, not this one. Okay, so let's do this one. We need to check, is this number prime or not? Prime or not? So to check 323 is prime or not, what we need to do, we need to take square root of 323. So no, if you use square root, so what we'll get is 17.97. And then I am writing all prime numbers from 2 is first, up to largest, up to the 17.97. So what we're writing, 2, 3, 5, 7, what else? 11, 13, 17. And now I'll take 323 and I'll divide by 2. Not divisible, I cross it. Then I'll take 323 and I'll divide by 3. Not divisible. You need to use calculator. Definitely not divisible by 5. So, and then we need to check not divisible by 17. And then we'll divide by 11, not divisible. 13, not divisible. But if you divide by 17, we'll get 323 equals 17 times 19. So, and then what conclusion? Is 323 prime?
No. No.
No, it's composite.
Composite. This is not prime. Okay. So, okay, so not prime. And so let's see next one. Let's do 151. We expect it will be prime. 151. Square root of 151 is 12.28. So this means what we're writing, 2, 3, 5, 7, 11. So prime numbers that less than equals 12.28. And then we'll check it. Not divisible, 151, not divisible by 2, not divisible by 3, not divisible by 5, because last digit is 1. And then you'll use calculator, you'll see also not divisible by 7 and not divisible by 11. So what is the conclusion about 151?
It's prime.
151 is prime. Okay, good. 151 is prime. So, okay, let's do one more problem about prime numbers. And a little bit change this problem. So you can write this problem at home. You can see it but I will choose more simple formula. Okay, so it's about formulas that we know for a cubed minus b cubed, a cubed plus b cubed, and one more formula that we know. I'm going to use to give you a different example. When we have formula a squared minus b squared. What is a squared minus b squared? No, we already discussed about this. A minus b times
A plus b.
a plus b. Good. And now I will give different problem. We need to find all values of n such that, no, I'll write something like n squared, and then I need to do something right there. So n squared, no, maybe 416. Or n squared minus, I don't know, minus 8. No. Oh, what example will be good to solve it? N squared minus, no, let's write 4. Find all n such that n squared minus 4 is prime. I don't know if, so this means about formula. Can we use this specific formula to get prime numbers? So how to do it? So suppose n squared minus 4 is prime. If number is prime, so number is divisible by itself or number is divisible by 1. Only 2 cases. Like 17. 17 is 17 times 1. Only 2 factors. But what we can see about n squared minus 4, this is n minus 2 times n plus 2. So this means we have prime number, and prime number it's written in the form, so as product of two integers, but it's prime in product of two integers. So this means we have two cases: n minus 2 equals 1, or second case n plus 2 equals 1. So this means one of the factor is 1, and we need to solve this equation. So what we'll get? N equals 3. And then n squared minus 4 equals 9 minus 4 equals 5. Or prime. Minus 3, 9 minus 4. Yeah, prime. We get prime. So formula works. Give us prime number for n equals 3. Or n equals negative 1. And then n squared minus 4 equals negative 1 squared minus 4 equals negative 3. So negative 3 is not prime number. So this means what is conclusion then? This is nice formula, but unfortunately using this formula we don't get a lot of prime numbers. We'll get only one for n equals 3, we'll get prime number is 5. Okay? So this is answer. And little bit more complicated example is when we have cubes, and you can read by yourself. Okay, this one. I will leave it. So now let's do next one. So what is written right there? Find prime factorization of integer 2808. So no, I will do different example. Prime. So we'll take integer. No, suppose this is 124. And we need to find prime factorization of this number. What we can say? 124 is divisible by 4. So what we'll get? 4 times 31? Yeah, 4 times 31. And what is 4? 4 is 2 squared times 31. So this is unique representation of the integer as product of prime numbers or powers of the prime numbers. But if you look this example, 2808, it's really easy to see number is divisible by 4. So we can write 2808 is 4 times 702. But also 702 is divisible by 2 and divisible by 3. So, and what we'll get? 4, 3 times 2, and if we divide this number by 6, we'll get 117. So this means how we can write number? 2 to the power. 4 times 2, 8, 2 cube. What else? 3 and 117. And this is his formula for this. But 117 also is divisible. Oh, sorry. 117 is 9 times 13. So this means we can rewrite more. So 9 is 3 squared. So what we'll get? 2 times 3, 2 squared times 3 squared, 3 times 3 squared, and 17 and 13. So this means we'll get 2 cube, 3 cube, and 13. And this unique representation of the number 2808 is product of integers or powers of integers. Okay. Let's do model arithmetic. So, okay, so what we'll see right there? This is some theoretical problem. So suppose A is congruent to B modulo n, and C is congruent to D modulo n. So then from this we need to get some formula. No, suppose we need to prove this. A squared plus C is congruent to B squared plus D. Modulo n. So let's see this problem. Now, what is the idea is? So we have a squared plus c. Okay, a squared plus c. And instead of c, what we can write? A squared plus c. Instead of c, what we can write? Say it. We can write d. So we can write d. So, but instead of a, I can write b. So we'll get b squared plus d. But to see it, why, if we have a is congruent to b modulo n, we need to see a squared is congruent to b squared modulo n. So by the definition, a is congruent to b modulo n, a is congruent to b modulo n, if this difference a minus b is divisible by n. Difference is divisible by n. But now to see a squared is congruent to b squared modulo n, I need to write difference of two numbers, a squared minus b squared, apply formula a minus b, help me, times
A plus B.
a plus b. And what we know? We know a is congruent to b modulo n. So this means a minus b is divisible by n. It's like n times k. So this means this is n times k. So this means a squared minus b squared divisible by n. If it's divisible by n, by the definition, a squared is congruent to b squared modulo n. So I'll give you a problem like that on the test. You have a lot of problems like that in my notes, okay? And also we have a lot of problems like that on the test, okay? So use this definition to see how from one equality, from congruence, so we'll get several more congruences, okay? So clear this. Okay. So now I'll little bit change this problem. Find remainder. If you'll take number and the right number, no, let's say 35 to the power 2024 plus 50. Now we need to check this number is divisible by 17. 35 to the power 2024 plus 50 is divisible by 17. Okay, so how to solve it? We write in 35 to the power 24 plus 50 is congruent to 0. For divisibility, remainder is 0. Modulo 17. We need to rewrite this expression, modulo 17, at the very end to get 0. Okay, so how to do it? And see what this is important, okay? This step is important. What is congruences? We'll take number and we replace by smaller number. What we can say about 50? How we can write 50? Modulo 17. So we'll take 50 and we subtract 17, 17, 17, what we get? So what we'll get? What is remainder? If we'll take 50 and divide by 17, what is remainder?
16.
It will be 16, yes, 16. Or we can write it's negative 1, modulo 17. So this means instead of 50, I can write negative 1. But what about 35 to the power 2024? No, you can say, what I can say about 35? 35 is congruent to modulo 17. What is remainder if you take 35 and divide by 17? What is remainder?
1.
1. Okay, so this means instead of 35, I can write 1. So this is 1 modulo 17. So this means what we'll get, instead of 35, I'm writing 1 to the power 2024, instead of 50, I can write -1. And what is total? So answer is 0. So this means what we'll see is hold this expression, 35 to the power 24 plus 50 is congruent to 0 modulo 17. It means if you take this number and we'll divide by 17, remainder is 0. So this means number is divisible by 17. Okay? Write this example and then I'll show you more. So let's go to next page, okay? So this is a little bit more complicated example, this one, but you can read it by yourself. Okay, let's do this one. Yeah, it's important. You'll see something like that on the test. Okay. We need to prove for all n greater or equals 1. This expression is divisible by 5. So let's rewrite it in modular form. Okay, so what we need to write? 3 to the power 5n plus 1 plus 2 to the power 3n plus 1. If it's divisible by 5, it's congruent to modulo 5. So for divisibility, what we need to write right there? For divisibility, if divisible, modulo is congruent to
0.
0. Okay, so this is to prove number is divisible by 5. We need to prove this number is congruent to 0 modulo 5. Now I'm going to rewrite. Okay, let's do it accurately. 3 to the power 5n plus 1. By using formulas of algebra, what we can write? 3 to the power 5. Then how many times? N times. And then times 3. And then I'll take 3 to the power 5 and 3 to the power 5. And what is 3 to the power 5? If you use calculator, it's 243. So, and 243 is congruent to 3 modulo 5. And I replace 3 to the power 5 by 3. And we'll get, instead of this, I will write 3. So this means I can write this expression will be written 3 to the power n times 3. Let's do this term. What is 2 to the power 3n plus 1? So what we can write? This is 2 cube to the power n times 2. 2 cube is 8. 8. So this means we'll get 8 to the power n plus times 2. But 8 is congruent to modulo 5. Help me find modulo 5. What is 8 modulo 5?
3.
3. So this means instead of 2 cubed to the power n, we can write 3 to the power n right there. So it's right there, 3 to the power n. And then coefficient is 2. And coefficient is 2. So this means we can transform our equation in the form 3 to the power n times 3 plus 3 to the power n times 2. And what we'll get? 3 times 3 to the power n, 2 times 3 to the power n, we'll get 2 to plus 3, 5. We'll get 5 to the power times 3 to the power n. And this expression is divisible by, say it, divisible by 5. So this means it's congruent to 0 modulo 5. And we solve problem. Okay, so 100% I'll give you something like that on the test. And keep in mind that we have problems like that in my notes too. Okay, so we have 518. Now let's solve next problem. So I have office hours on Thursday from 11 till 1:55. So it's 3 hours of office hours. You're welcome to come during my office hours and explain you more problem. Okay, so it will be in-person office hours. So let's do next one. Okay, prove for any integer a to the power 6 is congruent to 0, 1, or 4 modulo 5. So if we have modulo 5, so we have 5 possible remainders. And now we'll see 5 cases right there. I'll take formula for a to the power 6 and I replace a by 0. What we'll get? A to the power 6 is 0 to the power 6 and we'll get 0. So this means this case. Good, works. So what is next? Instead of a, I'm writing 1. What we'll get? A to the power 6, 1 to the power 6 is 1, modulo 5. This case. What is next? A is congruent to 2, modulo 5. Instead of a, we write in 2, we'll get 2 to the power 6. What is 2 to the power 6? It's like 2 times 2 times 2, 6 times. And this will be 64. And 64 is congruent to 4 modulo 5. So this means this case. And then what is a case A is congruent to 3 and A is congruent to 4 modulo 5. Instead of 3, I can write -2. If I'll take 3 and subtract 5, we'll get -2. And I'll take formula and substitute -2. We'll get -2 to the power 6 is 64. And again, we'll get 4 modulo 5. In the last case, a to the power 6 is congruent to, instead of a, I'll write -1, congruent -1 to the power 6, and we'll get 1 modulo 5. So this means in all 5 possible cases, we have only 3 answers, 0, 1, and 4. What is written right there? Okay, now I'm going to give you a different problem. Okay, so let's see. And this type of problem that I will write right now, possible problem on the test. Okay, so now I'm going to give you a different problem. So, and I will use whiteboard. No, I'll write something like that. A cube plus 8a is divisible by 3. Okay. Proof that for any a, I'll give you something like that. Even though you don't see it in review, but now I'm explaining this problem. For any a cube plus aa is divisible by 3. Okay. Let's rewrite this problem. A cube plus aa congruent to modulo 3. What we expected if a divisibility by 3? What we expected on the right hand side? It's congruent to 0. So this is, we need to rewrite like this. And then divisibility by 3. We can say, oh, we have only 3 cases. And we need to investigate these cases. So what is case? A is congruent to 0. And we write in a cube plus aa. And instead of a, I'm just substituting 0. We'll get 0 cube plus a times 0. And what we'll get? What we get? 0 modulo 3. So this means, oh, for this case, true. So we expect it to get 0. So next is a is congruent to 1 modulo 3. And we write in a cube plus aa is congruent to 1 cube plus a times 1. And what we get? Say it. 1 cube, 1 plus 8, we get 9. And what we can say about 9 modulo 3? 9 is divisible by 3. So this means we'll get 0. True. And then the last case, A is congruent to 2 modulo 3. We write in A cubed plus A times A, 8 times A, and instead of A, I'm writing 2. What we'll get? 2 cubed plus A times 2. No. 2 cubed is 8 plus 16. What we get? 24, and 24 is congruent to
0 mod 3.
mod 3. So this is also true. Okay. So I'll give you something like that on the test. So if divisibility by 3, how many cases? 3 cases.
3.
If
3.
divisibility by 4, how many cases?
4.
4 cases. Yeah. And if divisibility by 2, 2 cases. And you will substitute this just numbers and see, and you expect it to get number that is congruent to 0. If it's modulo 3. Okay. And the last topic to discuss, this is section 4.4. Okay, linear congruences. Okay, so now I explain you linear congruences. If you have extra time, I'll show you more different forms. Okay, so whatever you like. So let me erase it. Okay. So this is what we discussed before this break. Okay, so suppose we have equation A times X is congruent to B modulo N. One of the important ideas related to this equation is how to rewrite it. A times X is congruent to B modulo N. It means difference AX minus B is divisible by N. So this means we can write like this. We can write this equation in the form A times X minus B equals modulo N, N times K, or minus N times K. Or we can write like this, AX plus NK, and Y, sorry, Y, and Y equals B. What is name of this equation? What we'll see right there, AX plus NY equals B. It's just what we discussed at the beginning, the Fontaine equation. And so this and this is the same, just written different way. So A times X plus NY equals B. And we need to find this solution. But we know how to solve these two equations, okay? So to do it, to write this solution, first of all, we need to check existence of the solution. And we did it at the beginning of this session. We need to find greatest common divisor, and we'll take A, coefficient for X, and then coefficient for Y is N now. We need to find greatest common divisor of A and N, and this is D. And we need to check B is divisible by D. Okay, B is divisible by D. So if B is divisible by D, solution exists. But even we can say more, it will be D solutions modulo N. Okay, so and to solve these problems, first we will consider case when D, what we'll get, D equals 1. We just need to find one solution. Okay, and then I'll show example when we have D solution, if D is not equals 1. Okay, so this will be basically two problems. Let's do it. Okay, so let's solve this equation. 3x is congruent to 14 modulo 22. So the original equation is ax is congruent to b modulo n. So we write in a equals, what is value of a?
3.
3, okay. What else is important for us? B equals 14.
14.
N equals
22.
22. So now we need to find D. What is D is? This is you need to memorize. Greatest common divisor of A and N. So D equals greatest common divisor of 3 and
22.
22. And greatest common divisor is
1.
1. Okay. So now we'll take B, so 14. I'll divide by 1. And we say it's divisible. So what is then what we can say about this? One solution exists. Okay. Now we need to find solution. Okay. So first of all, you need to check existence of solution, and then how many solutions, and then you need to find solution. Okay. So it's like different parts. A, B, N, greatest common divisor. B is divisible by D. If it's divisible, we have existence of solution or solutions. But how many solutions? It's what is number of D. In this case, D equals 1, one solution. Okay. So now I'm writing this equation, and I'll find this solution. It's to find this solution, unique solution, we need to use completely different idea. When we have congruent equations like this, we can multiply our equation by integer, and we don't lose anything. We still get we can transform it in right form. And what is the idea? This is its key moment. We'll have this equation 3x is congruent to 14 modulo 22, and we need to multiply by number such that in front of x, instead of 3, we'll get 1 or negative 1. Or 2, or negative 2, some kind of smallest as possible number. If it's 1 or negative 1, it's perfect. But if it's difficult to see, no, we'll do step by step. No, what do you think? We'll take this 3x is congruent to 14 modulo 22. If you have modulo 22, what is next numbers? What we have around 22? 23. 23 is congruent to 1 modulo 22. So it's like good to have 23, but how to get 23 out of 3? Difficult to say. So, but what is next number around 22? 21. But 21 is congruent to
Negative 1.
negative 1. Okay, good. Negative 1. So this means difficult to get 23 after multiplication 3 by integer, but very easy to get 21 out of 3. So we'll take this equation and we'll multiply by
7.
Multiply by 7. Write it. Multiply by 7. So what we'll get? 21x is congruent to, what is 14 times 7? 98. And modulo 2, 22. And then instead of 21, what I can write now?
Negative 1.
Negative 1, so we'll get negative x is congruent to, and also 98 is big number. So what we get, instead of 98, I can write, I'll take 98, I will divide by 22. It's 4 times 22, 88. So this means we'll get 10 modulo 22. So we'll get 10 modulo 22. So this means what is the answer for problem? X is congruent to
Negative 10. Mod
Negative.
22.
mod 22. No, if you don't like negative numbers, also you can write, oh, if I add 22 to negative 10, we'll get 12 modulo 22. So this means this is the answer for problem. Always check your solution. Always check your solution. Let's check it. So I'll substitute 12 right there. 3x, and instead of x, I'll write 12. We'll get 36, and then 14. We expect it is congruent to 14 modulo 22. Is it? 36 and 14. Yeah, 36 minus 14 will be 22 divisible by 22. So we check it, and it's true. Okay, let's do one more problem like that. Okay, and then I'll show you when we have more solutions. No, I'll write something arbitrary, like something simple. No, let's do like 5x is congruent to 7 modulo 9. Write it. A equals, B equals, N equals. So AX is congruent to B modulo N. So what we're writing, A equals 5, B is 7, N is 9, D is greatest common divisor of 5 and 9 equals 1. 7 is divisible by 1, so we have D equals 1 solutions, just one solution. How to find this solution? Multiplying by some integer such that in front of x instead of y will get some number that is congruent to 1 or negative 1, modulo of 9. 5x is congruent to 7 modulo 9. What we can do? Tell me how to write it, how to rewrite this. Multiply by no, we'll just check numbers. What we can do? 0, we cannot multiply by 0, 1. No, 1, it's the same equation. So what is next? Multiply by, say it.
2.
Multiply by 2. Thank you. So if you multiply by 2, what we'll get? 10x is congruent to
14.
14 modulo 9. But they say, oh, great. Why? Because 10x is congruent to 10 is congruent to what we need in front right there. We're lucky. We all immediately get number in front. Instead of 10, what I can write? Modulo 9. What I can write?
1.
1.
Going to 1.
Oh, instead of 10, 1. So this means we'll get 1 times x. X is congruent to 14 modulo 9. And also we can simplify 14. So instead of 14, I can write
5.
5. So modulo 9. And this is our answer. Let's check it. No, check it. How to check? Take this formula and replace x by 5. What we'll get? 5 times 5 is congruent to 7 modulo 9. 5 times 5, 25, is congruent to 7 modulo 9. So 25 minus 7 is 18. 18 divisible by 9. True. So 18 is divisible by 9. True. Okay, let's do 2 more problems, and then we will be done with the review. And let me repeat again, we have Thursday, I have office hours from 11 till 1:55. You're welcome to come and answer also for different questions if about this review for test 2 and test 2. Okay, so let me clear this. Okay, so next problem is very easy because in this next problem no solution at all. So where no solution. Let me see. It's right there. So y no solution. What we get? A equals 5, A equals 3, B equals 5, N equals 6. Greatest common divisor of 3A and 6N is 3. But what we'll see, 5, it's not divisible by 3. So what is answer then? What is conclusion?
No solution.
No solution. Okay. And now the final problem. When we have more than one solution. So, and okay, let's do this one. Let's do it accurately. So 21x is congruent to 15 modulo 39. Write it. 21x is congruent to 15 modulo 39. And we will write in A equals 21, B is 15, and N equals 39. So then we need to say, we can say greatest common divisor of A and N, so this means 21 and 39 equals 3. So now it's not 1. So not 1. So, and we'll take B 15 and divide by 3. Divisible. So this means everything is true. So this means, so what is conclusion then? We have how many solutions? D solutions, and D equals 3. So 3 solutions. Okay. So this is important new case when not one solution, we have more solutions. Okay. To find these 3 solutions, first we need to rewrite this equation. And what is important right there, basically we'll take each term in this formula and we'll divide by 3. And we'll get new equation with D equals 1, we solve it, and then using this new equation, we can find total 3 solutions for original equation modulo 39. Okay, so it's written 21x is congruent to 15 modulo 13. So this means difference 21x minus 15, this difference, is divisible by 39. So I'm writing divisible by 39. This is definition. And this linear equation, first term is divisible by 3, second term divisible by 3, and 39 divisible by 3. And I'll divide each term by 3. And what I can get? 7x minus 5 and equals 13y. And how to rewrite this new equation? It will be 7x is congruent to 5 modulo. Now instead of 39, what we'll see right there? Modulo
13.
13. So this means to solve original equation with modulo 39, we need to solve different equation with modulo 13. Okay, for this new equation, A equals 7, B equals 5, and N equals 13. Greatest common divisor of 7 and 13 equals 1. So for this new equation, D equals 1. So only one solution. So how to find this one solution? We'll take 7x is congruent to 5 modulo 13. And we'll take this equation and multiply by, and you need to tell me what we can do to multiply, such that we'll get instead of 7, 1 or negative 1. So multiply by, no, what is first number we can use to multiply? Multiply by, just check it. Like 0, we cannot use 0, we cannot use 1. No, what is next value of for multiplication? What we can use? Multiply by, say it.
2.
2. Multiply by 2. And what we'll get? 14x is congruent to 10 modulo 13. It's still 13, like we did it before. But instead of 14, what I can write?
1.
1. Okay, so this means what is answer for this problem? X is congruent to 10 modulo 13. This is answer for not original problem, for this one, modulo 13. So this means X is congruent to 10 modulo 13. But we need to check modulo 39. And we write in this solution also will be solution for modulo 39. But how to find? We know we need to find 3 solutions because D equals 3 right there. D equals 3. To find these 3 solutions, one more important idea. We'll take 10 and we add 13. And what we'll get? Next solution. X is congruent to, say it, 10 plus 23 modulo 39. And then we add one more 13. So 23 plus 13, what we'll get?
36.
86 modulo 13. Or modulo 39. So this means we'll get 3 solutions, modulo 39, and 1 solution, modulo 13. This is some kind of, you change divisibility from 39 to 13, you'll get just 1 solution, but if you look at like modulo 39, it will be 3 solutions, and you need to find them. So it's like probability what you'll get problem like that, relatively high. No, not say 100%, but close, okay? So let me stop, let me erase it. Okay, any questions? So I teach now in a couple minutes new class at 6. So any questions about this review or no questions? Okay, see you then on Thursday during my office hours and then also in 4:30 on Thursday. Okay, thank you. Thank you, everybody. Bye.